Good morning all. I've set my camera quite high this morning because I have a big box which won't fit on the bench anyway. What's in the big box? A solar panel. Quite a big solar panel. So I've taken the camera even higher with the hope of getting most of this in. So what this is a 30 watt solar panel. It's a 36 cell, so we've got 4 cells by 9 across, terminated in 2 wires with crop clips. I'm going to be cutting those off. And the most important thing is that it's flexible. So I can bend it a little bit, but I don't dare bend it too much because these look to me like standard silicon wafer solar cells. So on the back you can get a little idea of how this is wired up. We've got these single tabbing wires running onto a connection point on the back of the cell, running across to the front of the next cell and so on, and then banked 9 cells, runs across, back up the other 9, and then back down again, and then back up again. So 36 cells all in series. Connection box here, that's been hot glued onto the back of this sort of 2-layer, I don't know what this is, what plastic it is. Maybe the listing would throw some light on that. Now there's a connection box here, and fortunately this cover just slides away. So let's get in a bit closer on that. Now in the connection box we have a bypass diode. You can see that it's connected across the solar panel from negative to positive. Bypass diodes are really interesting. I'll have to do a video on those one day, but they're quite complex how they work and what they do. But it's not an anti-backfeed diode because that would be in the path of either the red or the black wire. No, this is across the solar panel, so that's bypass. So this says on it SP 30 watt 12 volts. Now that's interesting in its own right because you're only going to get 30 watts at the max power voltage, which for a 36 cell panel is going to be more like 18 volts. So it's really 30 watts at 18 volts. I think what they mean by 12 volts is that you can use it in conjunction with the crop clips to charge a 12 volt battery. Right, it seems there's a peel sheet on the front plastic, so let's get rid of that. So now what this is really is just, well, I guess 2 layers of plastic with these cells sandwiched in between. But as I say, these just look like regular silicon solar cells, which, as far as I know, I've never really tested it, are quite brittle. So I don't really want to flex this thing too much for fear of breaking a cell. So this solar panel came from Banggood.com. It's the 30 watt 12 volt semi-flexible solar panel device battery charger, £33, or about $40 US thereabouts. Right, what does it say about okay, so high conversion efficiency, long service life, full power, the unique process component, beautiful and strong anti-snow. I don't really understand all that. Okay, size is 540 by 350. Length of alligator wires is that. Now this is interesting. Power 30 watts, only under the condition of intensity 1000 watts per square meter, that would be. Temperature 25 degrees and pressure 1.5 PA, not sure what that is. Now we're not going to get 1000 watts per square meter today because it's October and this is the United Kingdom, and no way are we going to get 25 degrees. Actually, you get a higher voltage out of solar panels when the temperature is cooler. So in that respect, today might be better. Working voltage 12 volts. Yeah, that's an interesting one. Maximum power voltage will be more like 17 or 18 volts. If you connect this directly to a 12 volt battery, then yes, the solar panel voltage will be 12 volts or a little bit higher than that, presumably, if the battery is reasonably well charged. So a little bit misleading, that 12 volt spec. Now, Banggood page listings always have a healthy supply of photographs, so we've got lots of them, of the front and the back. And what's happening in reviews? Mostly good, it would seem. Right, the all-important weather today for High Wycombe. Oh, look, a bit of sunshine at 2 o'clock this afternoon. It's not very warm though, is it? Are you seeing what I'm seeing? Reflected in this panel, a little bit of blue sky there in amongst the grey. I might actually be able to test this panel, see if I can get 30 watts out of it. Right, let's cut off a healthy length of this wire because, oh, that's interesting. I would have just shorted that panel out. I wonder if it's generating anything. Probably not face down. I can reuse these for something else, and I don't want crop clips on this panel today because I'm going to connect this to an old thing that I built years ago. And that is this. It's what I call the LAM, the Large Array of Miniature Bulb. It has bulbs. It has 3 bulbs in series. These are 6-volt bulbs, so that's 18 volts. And I've got lots and lots of columns. Lots and lots and lots of columns. This thing's about 3 foot long. So that I can tighten up as many of these bulbs as I want and draw as much current as I want. It's my crude electrical DC load. Let's take it outside and give it a try. Now, in the interests of full disclosure, and people have indicated that they would like a full disclosure, this item was sent to me at no cost. Right, so here's my setup. There's the LAM, the Large Array of Miniature Bulbs. Oh, I wonder if I can get an end-on picture of that. Oh yeah, that looks rather good, doesn't it? Now, they don't appear to be lit, even though they are connected up to the panel. It's overcast at the moment. That's probably because they're all screwed in, so they're loading the panel so heavily that it's unable to generate any significant voltage. So I'm going to start unscrewing them. Right, let's do these big ones first. You only need to unscrew one, of course. Unscrew them so that the connection is broken. I hope this thing still works. So I'm just going to unscrew as many of these as I need to unscrew to try and get something to light up. Still doesn't appear to be doing so. Let's just keep going all the way down the line. Is it going to light up? Probably not with me blocking the panel. Let's just leave the last 3 rows on. No, they're not lit up. Time to get my meter. Right, that's connected up down there. And yeah, I've got 20 volts coming out of the panel. That seems to be fairly consistent. No loose connections. So is it my LAM that's got loose connections? Almost certainly. The sun's actually come out. I got a feeling these nuts are loose. So let's tighten them up if I can get the spanner on there. Yeah, I think those nuts may be a bit loose. Oh, I'll have to do this without holding the camera. Right, up at the business end of this unit, I've now got 1 row of these bigger light bulbs. I can't remember what they are, about 2 watts or something each. And we've got some hazy sun, so 15, 16 volts there. Let's put another row on. Now that immediately loads the panel heavily and it drops to 5 volts. So can't put 2 rows of those on and maintain maximum power voltage, but 1 set of those bulbs, the sun's gone in now and they're fading out rapidly. Sun's come back out and they're coming back on. And we're getting, well, close to maximum power voltage, about 15 volts. So, yeah, now is that 30 watts? Unlikely, with just that set of 3 bulbs. Looks more like about 6. Then it is October. Now we need to do this in a little more rigorous way, I think. But just before doing that, let's have a bit more of a play. Now the reason I put these smaller bulbs at this end, it's hard to see with the sun on the bulbs. It's a bit of a failing in this system, really. These smaller bulbs means I can turn more of these rows on. I could have a look at these bulbs and see what power rating they are. There's one missing there. But they're all lighting up reasonably well. I ought to put this thing in the shade, really, because you can't really see whether the bulbs are lit very easily. Right, slightly better arrangement now. The panel is tipped up quite high in the sun to catch this fairly low October sun, and the lamb is now sat here partially in shade so that we can see those light bulbs lit up. But that doesn't tell me how many watts I'm generating, so what I really need is a watt meter. So I'm going to use this Ruideng watt meter that I got in the other day with the remote display, which I can put somewhere where we can actually see it. So what I need to do is cut this wire so that I can hook up the watt meter in line with the solar panel. Now, shall I do that with the power on? That would be a bit of fun, wouldn't it? How do I do this holding the camera and everything at the same time? That's probably a little bit too long. Right, let's cut it there. That will short out these lamps. I can't tell whether it shorted them out or just cut them off, but okay, that's the wire cut. Let's wire it all up. Right, so there's the watt meter module. Now I've connected USB out on that module to the actual display unit, and that gives you a different symbol up on the top left. Rather than wireless, it appears to be transmitting wired. Now from the manual, what I gleaned is that this is RS485, so it's a serial communication between the display unit and the base module. So that's pretty neat. So the flexible solar panel is mounted up on the arm of this bench here so that I don't keep blocking it with my own shadow. I've got 3 rows of bulbs on, and currently we're only showing 2.8 watts. So what I want to do is get that in shot while I now start turning bulbs. So let's add in a row of bulbs. That's 5 watts. Where am I? I'm there. Add in another row of bulbs, 5.4. Another one, 5.2. Right. 6 watts. So has the sun come out a bit? I don't know. Let's keep adding them. 5.6. It's a manually controlled electronic DC load. It's a little bit flaky, but that seems to have dropped down again. No, it's going up. I think it's because the sun is poking out. Let's add a few more rows. 5, 6 watts. This is behaving rather strangely. 4. The bulbs are dimming down. So I've overdone that, so I need to back off. So what I'm trying to do is find the maximum power point. 6, 7 watts, 7 watts, 7 watts, 6. So it looks like at the moment, and I think the sun is fairly hazy, I'm only managing to get about 7 watts out of this panel. Let's have a look at the sky. Right, I've got a couple of welding glasses here, but they're all covered in water because they've been sat outside. So I'll dry one of these off and stick in front of the camera. Right, I think the sun is partially blocked by cloud, but to the west, and we get our weather from the west, there is quite a bit of blue. So when that comes over, I'll repeat this test. But one thing I wasn't doing while I was adjusting these light bulbs was watching the voltage. So let's do that, because maximum power voltage, let's turn on some light bulbs, it should be about 18 volts, 17 maybe, so 17.5 volts, 9 watts, 15 volts. Now that would probably be dropping back down 7 watts. Let's release some bulbs, they're a bit wobbly. So probably around 17, 18 volts. We're getting 8 watts. 13, that's too low. 17, that's a big jump, isn't it? That's one row of light bulbs I'm adjusting there, just turning that row on and off. Because they're a bit wobbly and the contacts are a bit intermittent, I'm not getting a very convincing result. Now I know what you're doing. You're shouting at the screen saying use an electronic DC load, and I do have one somewhere, so perhaps I should, but let's just see if I can get this voltage back up. 17 volts, 9.2 watts, 18.5 volts, 7.8 watts, 17.5 volts, 9.1 watts. So I think that's probably about maximum. 17.5 volts I think is fairly typical maximum power voltage for a 36 cell panel. The variation in watts is really the sun being partially behind a cloud. So I think that's probably about it for the moment. That's not the 30 watts that this panel claims, but then I haven't got full sun. I haven't got their conditions, which was 1,000 watts. Oh, the sun's gone right in now. 1,000 watts per square meter. So let's wait for some blue sky, I think. No, cloud, you're going the wrong way. The problem is the cloud isn't actually coming from the west. It's coming more from the southwest, I think. And there's another big block of cloud there. Well, that's just going to block the sun. You're not helping me do my experiment. Well, a little bit of sun now, and I've got 18 volts and 9.6 watts. Let's turn on another row, try and bring that voltage down a bit. That's... the sun's gone. Can't believe it, there's a sliver of cloud just blocking the sun. I mean, over in, I don't know, Stokenchurch, a couple of miles away, they've probably got full sun with all that blue sky, but we just don't get it here. It's just me. Is this me being just a whingy old bloke, or am I being picked on by the weather? And now the sun's riding across the top of the cloud. It's like poking its head out from behind a duvet. Well, briefly, 10.1 watts. Yes, very briefly. The sun's completely gone now. So I'm abandoning this test because, because of the weather. So although I can't test the power coming from this panel, ironically now, we have full sun. How interesting is that? The panel on the left is my 20 watt panel. The panel in the middle is the Banggood supplied 30 watt flexible panel, and the panel on the right is a 15 watt panel. Now, in terms of surface area, the 30 watt panel in the middle looks like it's about the same as the 20 watt panel on the left, and the 15 watt panel on the right looks correspondingly smaller. So I can't see quite how that 30 watt panel could generate 30 watts. I mean, the solar cells look like fairly conventional cells. There's nothing special looking about them. So for that to be 30 watts, I think it would have to have some very efficient solar cells, and I'm not 100% sure it's got them. But certainly it does benefit from being super lightweight. I mean, it just weighs almost nothing. It's fantastically transportable. It is flexible, but I'm not sure how far I dare bend that, given that these do look like standard silicon cells. And I know they break easily. I just can't understand how they haven't broken already, to be quite honest. I suppose ultimately this method of construction is really about price, isn't it? I mean, this is just 2 layers of, it looks like polycarbonate. Possibly it isn't polycarbonate, but yeah, just 2 layers of plastic. The cells tabbed and wired together, bonded between the 2 layers, so they are sealed. And then this box glued to the back. It's certainly going to be a cheaper construction than this sort of framed solar panel with the aluminium surround. So I'm sorry that I can't verify whether this is actually 30 watts. My guess is it's going to be more like 20 watts because it's almost exactly the same surface area as my 20 watt panel. Let's just see how they line up side by side. Well, it's almost exactly the same width. What about length? It's almost identical, ever so slightly shorter perhaps. But certainly when I win the lottery, I will be buying myself a little apartment out in the Mediterranean. Malta I'm very keen on, particularly the North Island, Gozo. It's absolutely beautiful. And I'll take all this stuff out there and with uninterrupted sun, I'll do some proper testing and let you know whether this is 30 watts or not. So that was a little look at the 30 watt, or probably more realistically 20 watt flexible solar panel. This one supplied by Banggood. And that's another frustrating day of so-called sunshine in the United Kingdom. Cheerio.